Welcome to this free online course on machine learning by MT Learners. In the previous video, we have talked about machine learning. In this video, I am going to define what is probably the most common type of machine learning problem, which is supervised learning. I will define supervised learning more formally later, but it's probably best to explain or start with an example of what it is, and we will do the formal definition later. Let's say you want to predict housing prices. A while back, a student collected data set from the city, and let's say you plot the data set and it looks like this. Here on the horizontal axis, the size of the houses in feet, and on the vertical axis, the price of houses in the thousands of dollars. Let's say your friend owns a house whose size is 750, size in feet as 750, and he wants to predict the price of the house. So how can the learning algorithm help you? One thing a learning algorithm might be want to do is put a straight line through the data and also fit a straight line to the data, like this straight line to the data. Based on that, it looks like that his house is going to sell for almost 150 or above $1,000. But maybe this isn't the only learning algorithm you can use, and there might be a better one. For example, instead of fitting a straight line to the data, we might decide that we want to put quadratic equation that will goes like this, somehow like this. So according to this, his house is going to sell for almost 2000 $2,000. One of the things we will talk about later is how to choose and how to decide, do you want to fit a straight line to the data or do you want to fit a quadratic function to the data. There's no fair picking whichever one gives your friend the better house to sell, but each of these would be a fine example of a learning algorithm. So this is an example of supervised learning algorithm. The term supervised learning refers to the fact that we give the algorithm a data set in which the called right answers were given, like some labeled data. These are the labeled data, prices of the houses according to the size of the houses. So this is supervised learning algorithm. That is we gave it data set for houses in which, for example, in this data set we told it what is the right price. So what was the actual price that house sold for, and the task of the algorithm was to just produce more of these right answers, such as for this new house that your friend may be trying to sell. To define a bit more terminology, this is also called a regression problem. This is a regression problem. By regression problem, I mean we are trying to predict a continuous valued output, namely the price. So technically, I guess prices can be rounded off to the nearest cent. So maybe prices are actually discrete value, but usually we think the price of a house as a real number, as a scalar value, as a continuous value number. And the term regression refers to the fact that we are trying to predict the sort of continuous values attribute. Here's another supervised learning example. Some friends and I were actually working on this earlier. Let's say you want to look at medical records and try to predict if a breast cancer as malignant or benign. If someone discovers a breast tumor, a lump in their breast, a malignant tumor is a tumor that is harmful and dangerous, and a benign tumor is a tumor that is harmless. So obviously people care a lot about this. Let's see collected data set. Suppose you are in your data set, you have on your horizontal axis the size of the tumor, and on your vertical axis 0 and 1. 0 for benign and 1 for malignant. So let's say your data set looks like this, where we saw tumor of size this, which is turns out to be benign. 1, 2, this size, and so Mm. Sadly, we also saw a few malignant tumor cells, one of the size like this, one of the size this, and so on. So in this example, I have 5 examples of benign tumors shown down here and 5 examples of malignant tumors shown with the vertical axis value of 1. Let's say a friend who tragically has a breast tumor, and let's say her breast tumor size is somewhere between here. Here. The machine learning question is, can you estimate what is the probability versus the chance that a tumor is malignant versus benign? To introduce a bit more terminology, this is an example of classification problem where the output is discrete value like 0 or 1, yes or no. The term classification refers to the fact that here we are trying to predict a discrete value output 0 or 1, malignant or benign. So now in this example, we use only one feature, one attribute, that is tumor size, to predict whether a tumor is malignant or benign. In other machine learning problems, when we have more than one feature or more than one attribute. Here's an example. Let's say that instead of just knowing the tumor size, we know both the age and the tumor size of the patient. In that case, maybe your data set would look like this, where I may have set of patients with those ages and that tumor size, and they look like this. And different set of patients that look a little different, whose tumor turned out to be malignant as denoted by the crosses. So I will look like this. So let's say you have a friend who tragically has a tumor, and maybe their tumor size and age falls around here, and so it falls around here. So what the learning algorithm might to do is fit a straight line to the data, try to separate out the malignant tumors from the benign one. So the algorithm may decide to put a straight line like this. It will separate benign ones from the malignant ones. With this, hopefully we can decide your friend's tumor is more likely. If it's over that, hopefully your learning algorithm will say that your friend's tumor falls on this benign side. And is therefore more likely to be benign than malignant. In this example, we had two features, namely the size of the tumor and the age of the patient. In other machine learning problems, we will often have more features. It turns out one of the most interesting learning algorithms that we will see in this course as the learning algorithm that can deal with not just 2 or 3 or 5 features, but an infinite number of features. But it turns out that for some learning problems, that what you really want is not to use like 3 or 5 features, but you want to use an infinite number of features, an infinite number of attributes, so that your learning algorithm has lots of attributes or features. So how do you deal with an infinite number of features? How do you even store an infinite number of things in the computer when your computer is going to run out of memory? So when we talk about an algorithm called the support vector machine, there will be a neat mathematical trick that will allow a computer to deal with that infinite number of features. Just a quick wrap-up question. Suppose you are running a company and you want to develop learning algorithms to address each of two problems. In the first problem, you have a large inventory of identical items. So imagine that you have thousands of copies of some identical items to sell, and you want to predict how many of these items you sell over the next 3 months. In the second problem, problem two, you have lots of users and you want to write software to examine each individual of your customer's account. Decide whether or not the account has been hacked or compromised. So for each of these problems, should they treat it as a classification problem or as a regression problem? For problem one, I would treat this as a regression problem because if I have thousands of items, well, I would probably just treat this as a real value, as continuous value. Therefore, the number of items I sell as a continuous value. For the second problem, I would treat that as a classification problem because I might say set the value I want to pick 0 to denote the account has not been hacked and set the value 1 to denote an account that has been hacked into. So just like your breast cancer where 0 is benign and 1 is malignant, so I might set this be 0 or 1 denoting on whether it's been hacked and have an algorithm try to predict each one of these two discrete values. Because there is a small number of discrete values, I would therefore treat it as a classification problem. So that's it for supervised learning. In the next video, I will talk about unsupervised learning, which is other major category of learning algorithm.